Hi, my name is Charumati.
In four-stroke engines, the power is obtained in four-stroke ones. After power obtained in power stroke, the burnt gases have to be allowed to the atmosphere during exhaust stroke. In exhaust stroke, the exhaust valve opens and the burnt gases escapes to the atmosphere. The exhaust manifold is a component which is bolted to the cylinder head of a car. Its job is to distribute exhaust gases to the rest of the engine, which helps to ensure an even and effective burn. They provide channel to carry very hot exhaust gases. The burnt gases may contain harmful gases and need to be cured before they become too dangerous. A gas curing system can help with this process by burning off any extra fuel that may have been added before the incident occurred. This allows for a controlled, clean burn of these hazardous gases without posing a threat to firefighters or civilians nearby. The gas curing system includes a generator which produces an electrical current through wires within the chamber. The heat from this current is transferred into a resistive wire mesh blanket that surrounds the gas cloud. So, after exhaust manifold, a catalytic converter is provided and it converts the harmful gases into harmless. The exhaust manifold and the catalytic converter are exhaust system components that are found on modern automobiles and light trucks. They are both important parts of the vehicle's emissions control system, reducing harmful pollutants released from the engine during combustion. The manifold is the first part of the exhaust system to receive spent fuel from all cylinders of the engine, while the converter contains a chemical mixture that converts carbon monoxide CO into less harmful carbon dioxide CO2. Now, we are going to learn the exhaust system components like exhaust manifold, catalytic converter, and how to remove and replace the exhaust manifold and catalytic converter.
Three types of catalytic converters: two-way converter, three-way single-bed converter, three-way dual-bed converter. Two-way converter designed to oxidize HC and CO, converting them into H2O and CO2. Three-way single-bed converter oxidizes HC and CO and also reduces harmful NOx into harmless nitrogen and O2. O2 in NOx is used to oxidize HC and CO. Three-way dual-bed converter has two chambers. A tube between two chambers provides O2 to the rare oxidation chamber supplied from the air pump. Two-way oxidation converters, also called oxidation catalysts, changes harmful HC and CO gases into harmless H2O and CO2. Used in older vehicles without O2 sensor. This oxidizing catalyst start working at temperature between 500 degree Fahrenheit and 600 degree Fahrenheit. Works efficiently when heated to 750 degree Fahrenheit, 400 degrees Celsius or higher. Three-way catalytic converters, used with O2 sensor feedback systems, reduces NOx and oxidizes HC and CO, either single bed design or double bed design. Single bed design is a single unit that reduces and oxidizes all three emissions at once. Double bed design has its reduction and oxidation parts in separate chambers within a single housing. Three-way catalytic converter needs heat and a regulated air-fuel mixture to work effectively. It is far less efficient when the mixture is too lean or too rich. The oxidizing part of the catalyst does not remove HC and CO very well at mixtures richer than 14.7:1. NOx reduction in the catalyst does not work well at mixtures leaner than 14.7:1. The air-fuel mixture in an O2 feedback system constantly fluctuates between rich and lean. This allows the oxidation part to operate when the mixture is lean and the reduction part to operate when the mixture is rich. Now, we are going to learn how to remove catalytic converter and exhaust manifold. First, disconnect the electrical connections from the oxygen sensor. Apply rust remover spray on all the fasteners in exhaust manifold system. Loosen the bolts and remove the silencer from the catalytic converter. Loosen the exhaust manifold nuts and remove the exhaust manifold with catalytic converter. Now, disconnect the catalytic converter from the exhaust manifold. Refit the exhaust manifold and catalytic converter in the engine. Emission analyzer readings. To test catalytic converter, an emission analyzer is required. During a converter test, there should be no exhaust leaks. The air injection is off. The catalytic converter is hot. Engine speed is 2000 rpm. With the engine running, watch the emission levels on the exhaust analyzer. They should drop. Look at the O2 reading. If it drops to 0, the car is storing O2 while the mixture is lean. Snap test can be done only when there is fuel control. This means there is closed loop and the O2 sensor is switching between rich and lean. To perform the snap test, snap the throttle open and let it drop back down to idle. This loads the catalytic converter with fuel. Watch O2 and CO. Check the rise in O2 as CO increases. O2 will continue to rise after the CO peaks. Check O2 at the point of peak CO. Less than 1.2% is good. At 1.2%, car is 80% efficient. Higher than 1.2% is bad.
Till now, we have learnt about the constructional details and working of exhaust manifold and the catalytic converter. Exhaust manifold is an exhaust system device which channels the exhaust gases to escape from the engine. Catalytic converter is fitted near the exhaust manifold and it converts the harmful gases into harmless.
Thus, we have learned to remove and replace exhaust manifold and catalytic converter.
Hope you are clear on this. Do this exercise with the help of your instructor. Thank you.